Alright, so welcome to the PetDoors.com simulation video. My name is Charlie, and I'm working with Rebecca Farr on this project, and this is kind of what we're going to be doing for the next couple weeks. So at PetDoors.com, they produce PetDoors. Each of these that you see here is going to be considered one unit. And one pet door or one unit has a bunch of little kind of pieces to it. So this is what a vert is, and these are going to be pretty prominent in the assembly process. So these little sides here are verts. This is a top, and this is a bot or bottom. And then this little thingy here where the flap kind of connects is a strike. And then this is the flap. So those are the main components to one unit. So let's talk about the facility layout real quick. There's a legend here. As you can see, the workstations in blue are for Builder 1, the workstations in gold are for Builder 2, and the workstations in purple here are for Builder 3. And then all of the grayed out areas are kind of storage that has mild interaction with the 3 workers that are going to be working on this plant. So, little quick discussion about the different builders' tasks. Builder 1 is going to be assembling the locking covers, which is the big plastic cover that covers the pet door. And then he's also going to be assembling flaps and taping the strike magnets. Those are the 3 individualized steps that Builder 1 is going to be doing. These last 4 here, deburring verts, processing verts, assembling frames, and boxing, these 4 are going to be shared with all 3 builders, so we're not going to get into too much detail here until the very end about that, but these 3 are the specific ones to Builder 1. And also, if they're trying to build 20, they've got certain quantities that they've got to build for each of these, like locking covers. You need 20 locking covers if you're building 20 units. If you're assembling flaps, you might need 40 flaps, depending on the variation of the product. And then strike magnets, you're always going to need double the total quantity that you're going to be building. Okay, so real quick, this is where Builder 1 starts. He starts by pulling from storage. He pulls some material from storage and brings it over to Workstation 2, where he will then proceed to work at Workstation 2. He will start assembling the locking covers, and then he might either assemble the flaps or do the tape strike magnets. It's kind of up in the air which one he does first. It really depends on what the other 2 builders are doing, because honestly, one of the things about this process that makes it a little bit unconventional is even though it's assembly line, all 3 builders have steps that kind of overlap each other. So first he will be at Workstation 2, and the nice thing about Builder 1 is he stays here until he's ready to start deburring verts and getting done with those last 4 steps that are common amongst the 3 builders. So after he's done assembling locking covers, assembling the flaps, and taping the strike magnets, he's going to get right to work on deburring verts, processing, and assembling frames. Builder 2. So the difference with Builder 2 is he cuts flap magnets, inserts them, and then he cuts vert magnets, and then he drills the verts. So the first couple steps with all the magnets he does at Workstation 1. He then moves over to the drilling station where he starts to drill the verts that are cut by Builder 3 at the saw. So Builder 3 will cut the verts at the saw, transfer them over to a cart that holds all of the material, and then he drills all of those verts after he's done cutting the magnets. So once he's done drilling the verts, he transports them to each workstation here. 1 here, comes back, 1 here, comes back, 1 here. 1 set of verts. And once he's done with all the verts, he moves over to his workstation, and then he proceeds to start on the common steps. Alright, Builder 3. So what Builder 3 does is he cuts all of the verts, and then he cuts the tops, bottoms, and strikes, and then he processes the tops, bottoms, and strikes. So starting over here, we keep the raw material over here, the stock. He pulls that and brings it over to the saw. He then cuts all of the verts out, and then once he's done cutting the verts, he puts them over here so that Builder 2 can start drilling all of those verts like we talked about in the last couple slides. So then after he's done drilling or cutting all those verts, he begins to pull more material from storage, and then he cuts the tops, bottoms, and strikes at the same saw. He cuts all of those to length, and then once he's done with that, he transports them up to Workstation 6, and there he processes the tops, bottoms, and strikes, which means he assembles them and puts them all together and cleans them off and polishes them, what we call processing. Once he's done processing at workstation 6, he's going to move over to workstation 5, and then he begins the common steps like the other two. And hopefully we should see all three workers kind of start on those common steps at around the same time. We hope to do it within 10 minutes of each other. That's one of our personal goals, but sometimes it just doesn't work out that way. And like for example, last time we went to go see a run, worker 1 was about half an hour late, and so that's just a problem that we want to kind of simulate and figure out what's wrong. So a little bit about modeling this process. This is kind of an unconventional process since there are 3 workers, but multiple workstations. Like there are definitely more than 3 workstations. So they go 20 units at a time at one workstation, they finish up, and then they go to the next workstation, and then they do 20 minutes at a time. And that's kind of it's kind of hard to model that. So that's going to be one of our challenges. The other one is it's not like there's inter-arrival times. It's not like, a line of customers decide to come through the door at a store or something like that. It's more like they have a fixed number of units that they want to manufacture in a given time period, and that's what they have to work with. So the sources aren't going to keep spitting out parts. They're going to have to spit out a fixed number of units depending on what we want to model. So I'm not sure how viable that is, but if that's doable, then that would be great. And then the other thing is they do one process at a time. So they go through one station at a time. So like builder 3, he can only cut, if they're doing 20 units, he cuts 40 verts because there are 2 verts to each one unit. So what he's going to do is he's going to cut those 40 verts and then pass them on to the next station. So that would be what we call source 1. And then he has to, after that, start on source 2, which is cutting the tops, bottoms, and strikes. So how do we reconcile that? Well, we have to have kind of triggers that, we start source 2 after source 1 has run out of its units to produce. So that's going to be, some compromises and reconciliations that we've got to sort of make to get this model running smoothly. And then finally, there are going to be tons of different parts that have to be combined using combiner tools so that it creates one final unit in the assembly. So that's going to be one of the other challenges that we've got, is combining a bunch of different parts into one final unit. So this is a pretty big, confusing process for those who haven't really gotten familiar with it. And having a hand-drawn model like we do here is not, it's going to be pretty tough to understand just based off of this. But the general idea is that you've got sources producing each individual part that's going to end up being in final assembly. So builder 3, he's going to kind of be in this area here. He's going to start with cutting the verts. Those verts are going to move over to being drilled in process 1 by the second worker. And then once he's drilled all those verts are going to be distributed evenly, probably by link weight or by sequence or something like that, to the deburring stations. And then while that's going on, the third builder is going to be doing the tops, bottoms, and strikes and moving it over here to process 2, where he's going to process those strikes. Then when he's done with that, he's going to go over to process 3 and start deburring verts, and then going through the deburring process, final, and boxing, the common steps as we call them. And all 3 builders are going to be working on these common steps, hopefully around the same time. But basically the whole model is we've got builder 3 doing his thing over here. We've got builder 2 starting up over here and then coming through here. And we've got builder 1 who kind of just sticks around in this little corner here and then gets started on the common steps in this workstation. So to the untrained eye or to the unfamiliar eye, yes, this looks pretty confusing, but really it's only a matter of figuring out how to cause triggers so that certain processes start after certain processes end. And that is essentially what we've got going on. Don't see too many challenges other than, there might be programming is going to be pretty difficult, especially with all these process triggers. I'm not entirely certain if sources can start after another source ends. I'm not even sure if sources are allowed to end, but that's going to be one of the things we get to discuss over the next couple of weeks. All right, thank you very much.